Welcome to another episode of the CERP 10 for 10 interview series. My name is June Kwan, and this week we'll be talking with Dr. Doug Seals. Dr. Seals is a distinguished professor of integrative physiology at the University of Colorado-Boulder. His lab has been focused on developing evidence-based interventions to blunt adverse physiological changes associated with aging, with a particular emphasis on cardiovascular aging. Dr. Seals obtained both his master's and his doctoral degrees in applied exercise physiology at the University of Wisconsin. It was a pleasure to have the opportunity to speak with Dr. Seals and obtain his thoughts regarding the potential role of nicotinamide riboside for healthy aging purposes. So without further ado, please enjoy your interview with Dr. Seals. Dr. Seals, welcome. It's great to have you on. Thank you for your time.
It's great to be here.
So to start, can you give us a quick introduction about your background and your research interests?
Sure. I'm a professor of integrative physiology at the University of Colorado at Boulder. And then we also have a medical school in Denver. So I have appointments in medicine, in cardiology and geriatrics medicine down at our medical school. But my primary appointment is up here on the University of Colorado-Boulder campus.
Great.
I direct a large, oh, I'm sorry.
Oh, go ahead.
I direct a large translational research lab. So this laboratory has been in business for almost 40 years, counting an earlier stint at the University of Arizona in Tucson. But we've been at the University of Colorado-Boulder for over 30 years now. And our research runs anywhere from studying high throughput molecular outputs to cell culture, research in mouse models, all the way up into studies in human subjects, including randomized clinical trials. So we are definitely a translational research laboratory. We span the whole translational research spectrum. And the last thing I'll mention for background is that our main focus is to establish evidence-based strategies to promote cardiovascular health throughout the lifespan. So how can we keep the cardiovascular system healthy throughout the human lifespan? A lot of our work is obviously directed toward aging as part of that focus on the entire lifespan. So that's a little bit of background on myself and the laboratory that may be helpful.
Wonderful. Thank you for that. Now, could you talk to us about your published research, as well as your ongoing research utilizing nicotinamide riboside chloride, for which ChromaDex has the patented form Niagen, and explain why you believe this research is of importance?
Yeah, our first set of studies were conducted in the early 2000 teens. I'd say 2012 to 2015. Those studies were actually done in mice, in young and older mice, and we used a compound that was a nicotinamide mononucleotide-based compound. And this was sort of a proof of concept study, and we published it in Aging Cell in 2016, I believe. And we were able to show that we could improve cardiovascular health in older mice by giving them this compound, this NAD boosting precursor in the drinking water. So again, it was a proof of concept study. And then we used those findings to conduct the first chronic administration trial of nicotinamide riboside, Niagen, in human subjects. So there had been one acute study that had been performed in human subjects, but ours was the first chronic administration of Niagen. It was a crossover design, randomized clinical trial, fairly small number of subjects. There were 24 healthy middle-aged and older adults. And the findings were, as we had hoped, one, that the treatment was safe and it was well tolerated in that population. Secondly, we proved that we could stimulate NAD plus metabolism in these healthy middle-aged and older adults. And then the most important finding from a physiological perspective or a health perspective was that we showed that this treatment with Niagen for about 6 weeks, and again, it was a crossover, so 6 weeks with Niagen, 6 weeks with placebo control, was able to reduce systolic blood pressure, the top number in the blood pressure reading, and arterial stiffness in the subset of subjects that had high initial systolic blood pressure and high initial levels of arterial stiffness. And that was an important observation because we were able to then in turn use those findings as preliminary results to obtain a funding from the National Institutes of Health, a grant from the NIH, and that has funded a parallel group, larger randomized clinical trial, again using Niagen to try to drill down and prove with some confidence that we could indeed reduce systolic blood pressure and reduce arterial stiffness in that pressure. And that trial now is entering its last phase. So we don't have any results yet, but we should be done with that trial by 2024 and have results to report.
Great. Wonderful. Thank you for taking us through that timeline. And it's very interesting to see how the research has gradually progressed and evolved over the years. So in connection with that, from your perspective, what's the significance or what's the potential of NAD boosting as it relates to healthy cardiovascular aging?
So, I think the main importance in what we're doing, especially with the current NIH-funded randomized clinical trial, is to determine if Niagen, if nicotinamide riboside supplementation can reduce systolic blood pressure. And that's critical, especially from a cardiovascular aging standpoint, because systolic blood pressure increases progressively with advancing age, at least in the general population. And it represents the primary modifiable risk factor for the increase in cardiovascular disease risk that it does occur with aging. And we're also interested in whether we can reduce arterial stiffness, because the stiffening of the arteries, especially what are called the large elastic arteries, the aorta and the carotid arteries, are the primary mechanism by which systolic blood pressure increases with age. So if we can reduce arterial stiffness and lower systolic blood pressure, we think that we can help reduce the risk of cardiovascular disease with advancing age. And if we could do that, reduce the risk of cardiovascular disease, we could really decrease a lot of age-related morbidity and mortality. So that's a very exciting prospect.
Indeed. So we look forward to seeing what those the results of those that clinical study they're running is. So now, do you have any advice for junior scientists who are looking to conduct research themselves on NAD and NAD precursors?
Yeah, I was talking with Dan Craighead, who is my junior colleague who's running our current Niagen clinical trial. And Dan mentioned that in his view, and I agree with this, that junior investigators, the first thing is to be aware of the broad range of research, both preclinical and clinical, that's being conducted with nicotinamide riboside and other precursors, because there's a vast array, as you know, of studies that are being conducted worldwide now, not only on Niagen, but other compounds. And it's important for those junior scientists not to just be aware of the published literature, but also active research that's not yet published. And there are various ways to monitor the ongoing research that hasn't been published. In the US, you can use tools such as the NIH Reporter, clinicaltrials.gov, and these other sources to make sure that you're aware of what's currently being assessed with regard to NR supplementation. Because you really want your idea, whatever that idea is, to be novel, obviously, and not replicating something that's already either under investigation or that has been published previously. But I think the bottom line for junior scientists is that NAD plus precursor related research is a field with great opportunities. It's a very, very exciting, very vibrant field for junior investigators. And it creates a lot of options for making important contributions to biomedical research. So I would encourage junior investigators to, if they have an interest in this area, to really do their homework, but to look forward to engaging in research opportunities in the field. It's very promising.
And thank you for that insight. Our last question is, how has being an investigator in the ChromaDex External Research Program, otherwise known as CERP, how's that been helpful to your research or your network?
I think for us, and talk to Dan about this also, is that we feel that the CERP does a great job of keeping investigators informed about research in the field. So again, there are so many studies that are being conducted, as is generally the case with science. It's hard to keep up with all of the different investigations if you were just doing it on your own. But CERP provides a mechanism for those of us working in the field to be aware of other investigators, other laboratories who are working on issues related to NAD plus precursor research. And through the emails and newsletters that CERP sends out, we catch a lot of studies that we might have otherwise missed. So I think that's quite valuable to us and other investigators.
Appreciate that.
Yeah.
And on a final note, where can people find out more about the work that you and your laboratory members are doing?
Yeah, they can look at our current website, which is one word, SEALS, SEALS, my last name, SEALS Laboratory, again, one term.com. And you can look at our current ongoing investigations, our grant funding, grant-funded projects, which includes this clinical trial on using Niagen, and also all of our publications and so on and so forth. So that's what I would recommend.
SEALSlaboratory.com. Okay.
Exactly.
So great. That concludes our interview. Once again, thank you for your time, Dr. Seals, and thank you for your insights. I really enjoyed having you on.
It's been a pleasure. Thanks a lot, June.
Thank you.